Hi all, very good day. Today I'm going to walk you guys through the machine learning model that I have created and the prediction on the one of the famous Titanic survival project from the Kaggle competition. So the model is supposed to predict how many passengers have survived the Titanic crash. So I'm PraveenKarthik. So let me walk you through the PPT first. So what I have done is I have done the data analysis part in Excel, and then I have moved on to the data analysis using the Jupyter, okay, and Python. Then what I've done is I've done the data cleansing in Python using ISNA and FILNA and standard deviation to clean up the data and the outliers, and then I have prepared it for the analysis and exploration. Then I've done the exploratory data analysis using different visualization tools like the Seaborn and Matplotlib, using the histogram plot and graphs. So from there I have done the feature engineering part, where I have modified a couple of features, say for example the sex, which is in categorical values, and I have to convert it to the numerical value. So I have done a feature engineering for that particular feature called sex, and from there uh, I have done some feature selection using select k best and chi-square across the different features to ensure that the more relevant independent features are identified or ranked based on some statistical methods using the chi-square, and select k best will rank those based on the chi-square statistical methods. And I have identified these four are on the top ranked independent variables. Those are really very much closely related to the target variable, which is nothing but the survival is the target variable. So coming back to this label encoding, coming back to this feature engineering on the feature called sex, the categorical data have been converted into the numerical values using the label encoding library, okay. And so the prediction is about the passenger data, and let me get into this Jupyter, the code that I have created to develop the model. So what I have done is I have imported the necessary libraries here, and what I've done is I've imported the necessary training data set for the Titanic survival prediction. And then what I've done is I've just gone through the training data, and I've checked whether any null values are present or not. So I could see some age having 177 null values. So what I've done is I've done some cleaning activity. So here, finding all the non values or the NaN values for the feature age, and its mean value is replaced for the non values or the NaN values. And using these lines of code, I have ensured that the mean of age is replaced in the null value records. So if you see this code, this piece of code will give you if any null values are present or not. So the cabin part, I have skipped it. I have not selected this feature to make the to create the model. So this is a histogram representing the model, the training data set that is actually present in the training data. So if you see, this is not a proper, it has some of the outliers on the right hand side, and it is skewed to the right side. And so I have done some feature engineering here. For example, because I want to have numerical values in order to predict the model, so I cannot have the categorical values, which is nothing but the textual values I cannot have in the model to predict it. So I have to convert the important features that are more relevant to the target variable. I have to convert it into the numerical value. So I have used the library called label encoder from the pre-processing sklearn, and I have converted the 6 into the numerical values, and I've added a new column sex_n. And if you see, the male will be termed as 1 and the female will be termed as 0 in the entire set. So this is a new column I have added. So from there what I've done is I've started creating I have to identify the feature those are more closely related to the predicted value called survival, where the survival is a binary classification problem statement in this particular project. So it has basically the classification are two types. One is binary and multi-class classification problem statement. So in this case of Titanic, the survival is binary classification where ones and zeros are the values or the class values that are present in this feature, where one is nothing but the passenger has survived and 0 means the passenger has not survived. So I have used the select k best and for the ranking of the features, and I have used the chi-square library in order to identify the feature ranking based on some statistical methods that runs in the back end. Okay, so what I've done is I have created it, and I have also got the scores of it. If you see the features, the scores of each of the features, this scores means that how close they are relevant to the target variable, how well they will be helpful to predict the target variable, and these are all ordered in the descending order, and a fair and a sex are the top two independent variables that are more relevant to the target variable. Then I have done some exploratory data analysis, and this data analysis will have used the histogram. If you see this plot, this is on the Titanic train data, this is on the fare feature, and if you see the this histogram, this data set is skewed to the right hand side due to the many outliers. So what I've done is I've used the standard deviation. I've taken one standard deviation and I have removed the outliers, and if you can see here, the right skew is much more reduced, and I didn't want to reduce furthermore because it might not have enough data to predict the model. Okay, so and then similarly I have done for the age also. If you see the age, it is also rightly skewed to the right hand side and also to the left hand side. So what I've done is, again I have taken the standard deviation, but here in this case I have taken 2 standard deviation instead of 1. So the standard deviation is utilized to is a statistical method to utilize to remove the outliers. Okay, so if you see, after removing the outliers, the same age is plotted in the histogram, and this is how the graph looks like. So primarily this graph, this line is called as the bell curve, and this is the Gaussian normalization, otherwise also called as. So from there I've given this particular data set, which is a cleaned up data set, which has no null values and it has no outliers to the best, and I have taken the count, mean, standard deviation and all those values for each and every numerical column. And basically these are the features, otherwise also called as independent variables. Okay, and now it comes to the prediction. I'm sorry, this is not prediction, this is the feature engineering. So what I have done is okay, this is prediction, and this is I have done the label encoding for the test data basically. So how I have the data is, I have a train data given by Kaggle and also the test data separately given by Kaggle. So I have to do the data cleaning for the test data also. So what I have done is I have checked for the null values of the NaN values, and then also have converted the categorical values in the sex feature into the numerical values using the label encoder. The same thing I have done it here also. And then here, this is where actually the actual prediction, the model fitting happens. So what happens here is I have written a reusable method where this method will predict the model, will fit the training data into each of these models: logistic regression, decision tree, random forest, ADA boost and gradient boost. All these 5 classification models, algorithms, the model that the training data will be fit into, and the test data will be predicted based on this, and this happens in a loop. Okay, and this is what it will. Let me run this. Okay, if you see, what it will do is it will return the prediction score for each of the algorithms that I have used across, because logistic regression, this is a regression problem statement, I mean this is a classification problem statement, and logistic regression is used for classification problem statement, and decision tree and random forest is also, all these 5 are used in a classification problem statement for the model prediction. And if you see decision tree classifier and random forest, these both will be using a technique called bagging technique, where each and every a random set of data will be created, and each will be predicted, and an average of that will be given as an output. On the other side, this to ADA boost classifier and gradient boost classifier, they use a technique called boosting technique, where they will assign weightage to each and every record in the data set, and whichever is wrongly predicted, that will be given more weightage, and first set will be predicted using algorithm say 1, and the second set will be predicted by a different algorithm, and an average of that will be taken as a score in case of the boosting model algorithm technique. Machine learning technique, and these two belong to that boosting technique. So I have basically looped it here, and I have ensured that data cleaning is done, and for the test data, and ensured that no null values is there. And if you see, I have called this get model. This is the reusable method that I have created it here, and this model predicts that the score is 79.79 in logistic regression algorithm. Decision tree and random forest will have 98.98, ADA boost 0.83, and gradient boost 0.90. So this is based on the training data. The score of the training data accuracy is given based on the different algorithms used. So if you see, there is the decision tree and random forest are having a similar number. It is until all the decimal places are matching exactly between the decision tree and the random forest. The reason behind is, if in case the data set is very huge, there will be definitely a difference, but this data set is very small, hence there is no much difference between the decision tree and the random forest classification, because the random forest uses decision trees, multiple decision tree algorithm within it. So multiple decision tree methodology is used in random forest algorithm. So that is the reason it is predicting this, it is giving the same score. And also the other factor that is affecting, the other factor is that the model is very limited in number, it has limited features, and it is a small data set. Hence it is predicting the same number as the decision tree. If you see, this is the target set, okay, and if you see, I am giving in the get model reusable method, I am giving the training source as the data set to be predicted. Hence I am getting this particular values. Okay, these are the accuracy scores for the training data set. In this particular line, I am giving the Titanic test source as the model to be, as the data to be predicted. Hence it is giving a different number. If you see, still decision tree and random forest are the two algorithms, those are giving the highest accuracy score. And again, as I earlier mentioned, they both are same in number because of the smallest very smaller data set. So this is the model that I have predicted. So please share your review comments. Thank you.